Okay, so the first topic in this particular lesson or video is plotting rational numbers on a number line. So one of the first things you probably should know is the word rational. Rational means can be expressed as a fraction. Rational, R word. Rational is the R word for the F word. It just means it can be expressed as a fraction. So you're given fractions. So the first thing you need to do is put them in some sort of way that you understand. I think that's probably the best way. Here is a number line, okay? Some people change these to decimals, and that is that is one option if you understand decimals better. 1 and 5/6, it's -1 and 5/6. You know that if this is 0, this is -1, this is -2, you know that it's going to be -1 and 5/6. So it's going to be -1. It's going to be -1, and then it's going to be some fraction. 5/6 is the fraction. So I'm going to show you how I do it, and then I'll show you how to change it to a decimal. I personally change this into 6 pieces. So to change it into 6, let's see, this is what we're going to do. There you go. I've now marked 6 individual pieces, and you can go -1, 1, 2, 3, 4, 5. 5, it says divide it into 6 and take 5 of them. I divided this 1, because this is just 1. I divided 1 into 6 pieces, and then I moved 5 of them in the negative direction. Remember, negative just marks which direction you go from 0. 17/6, change that to a mixed number. I'm still going to get to the decimal piece, but change 17/6 to a mixed number. 6 goes into 17. And if you want, you can always do it this way too. 6 goes into 17 2 times, that's 12, and you get 5. Well, 6 doesn't go into 5, so the remainder is 5 over 6. So that becomes 2 and 5/6. Again, so you can mark 1, 2. It's going to be greater than 2 because it's 2 and 5/6. So it means we're in the positive direction. So we're going to go 1, 2, and now we need to get 5 out of 6 pieces. This means we cut this into 6 pieces. So we're going to cut it into 6. I usually just cut it in half and then do 2 even. It's a little harder to sometimes divide it into 6 pieces, so it's easier to cut it in half first. But 5, 6. So 1, 2, 3, 4, 5 out of 6, and it's right here. So that's going to be 17/6. And I forgot to actually mark that other one. Whoops. This is going to be -5. 1 and 5/6. -1 and 5/6. And this is 2 and 5/6, or 17/6. Some people do better with decimals. I really don't want you to do decimals if you don't have to, simply because it's a bad habit to just constantly move to decimals. If you're in a test, though, I get it. Here's how you'd have to do it by hand. Okay, 5 goes into 6. Wait, what am I doing? I'm sorry. I can't talk and work at the same time, apparently. This says, if you read it, it says 5 divided by 6. And that's what you do. 5 divided by 6. Decimal point comes after, add a 0, bring the point up. 6 goes into 58 times, which is 48. Bring down the 2. 6 goes into 23 times, which is 18, and you're going to keep getting repeated. So it's about 0.83. So if you're looking at this and you were imagining it cut into 10 pieces, you would go about 8 of them. So I missed one line, dang it. There. Okay. And you would imagine that you would go about 8. Okay. It's harder to do decimals sometimes in the small range, but you can work it that way to understand it. In the same way, 17 divided by 6. 7, the point is here. 6 goes into 17 2 times, that's 12. you get 5, bring it down, 6 goes into 50, 8 times, I don't know why I put a 0 there, that was weird, 8 times, and that's 48, and then look, 2.83, and then you can imagine that's about 0.8, okay? All right, we'll do the next one faster. Okay, this one says -5 sixths and 2 2/3. So here's my number line. -5 sixths. Notice that's not quite -1. -1 would be 6 sixths. I'm going to make this bigger so I can divide it into 6 pieces. Okay, divide it in half, get 2 lines, 2 lines. Okay, it says -5 sixths. So you're going to go in the negative direction. That's the positive. That's the positive is always to the right. Negative is to the left. We're going to go 5 6. 1, 2, 3, 4, 5. So right here. That's -5 6. And this side is 2 2/3. So 1, 2, 3. How many pieces do we cut the 1 into? 3. So 1, 2. So 1, 2, 3. 3 even pieces, and we're going to take 2 of them. So you're going to go, I'll take a different color. 1, from 0. 1, 2, and 2/3 right here. That is 2 2/3. Moving on. All right. This is basically just adding and subtracting integers and keeping track of data. So it says the table gives the temperatures in Fahrenheit in 5 cities at 6 a.m. on the same day. Use the table to answer the questions. All right, how much higher was the 6 a.m. temperature in Springfield than in Nome? So let's take a look. We got Springfield here. Hey, Santa Fe. Okay, we got Springfield here, and we got Nome, Alaska. All right, it says how much higher. So we're looking at the difference. So take a look. If we were looking at the number line, and I realize that I'm putting it flat, in a way, temperature is usually on a thermometer, and it's kind of viewed like this. Right? -33 is here somewhere, and Springfield is 41. So they're basically asking, what is the distance between these two? Okay, I often think of it in real terms and think like, okay, well, to get from -33 to 0 is 33. To get from 0 to 41 is 41. So you would add them together and you would get 74 degrees. Often with these kinds of problems, in my opinion, it's best not to try to memorize how to do them, but to think about them. Okay, it's much better to know what you're doing. All right, take a look at the second one. It says, by noon, the temperature in Nome had risen by 14. I mean, it had gone up 14 degrees. Okay, it says, what was the temperature there at noon? So basically, we're asking, what is, if we add 14, where are we? Okay, so that becomes -33 plus 14. Those are different signs, so we're going to subtract 33 over here on the side where nobody can see you working. Let's see, 13 minus 4 is 9, 19. -19. Subtract and keep the sign with a larger absolute value, 33. Okay, all right. Okay, for the next two problems, they're going to ask you about whether they're integers, non-integers, and rational or irrational numbers. So for that, you need to know about the number systems. Okay, how do we categorize numbers? When you're little and you first start counting, you start with what's called the natural numbers, 1, 2, 3, 4, 5. As you get older, you get to add on 0, which is the whole number system. I'm going to start with that just because you're older and we don't need to worry about natural numbers. But the whole numbers are all positive integers, including 0. Okay? Bigger than the whole numbers, the next level is integers. And I think I should do that a different color. Okay, integers. Integers are all the negative numbers. So -3, -2, -1, all of them. And 0. 1, 2, 3, to infinity, to negative infinity, to positive infinity. Then we get to what we call rational numbers. Rational numbers can be expressed as a fraction. Well, as A over B. So any whole number is rational. Why? Because you could put -3 over 1. Any fraction is rational. 1/4. I told you rational is the R word for the F word. 1/4, 2/3. That is rational. But you also can have repeating decimals. So something like 1.9 repeating is also rational because it is predictable. Okay? Predictable. If you think about it, rational versus irrational. Irrational people make no sense. They don't have logic, right? If you feel like you're having an argument with somebody and they're irrational, I'm just making this smaller to fit. It doesn't. There's an infinite number of irrational numbers and an infinite number of rational. All right, irrational numbers are pi. Any square root that isn't a perfect square. By the way, rational square root of 16 equals 4. That's rational. So the square root of 16 is rational. Over here, square root of 3 goes on forever and doesn't repeat. It's not rational. It's irrational. Square root of 3, square root of 5, square root of 6, any number that isn't a perfect square is irrational. Pi, because it goes on forever and never repeats. Any kind of repeating decimal with no pattern is going to be irrational, whereas rational is predictable. So you could also have something like 1.3123112, like if it just keeps repeating like that. Now erase that. Okay, so let's take a look. Okay. All right, question. Is it an integer or not? Remember integers? Integers are these numbers here, okay? So is it an integer? Yeah. Is it an integer? Yeah. Is it an integer? See that? That makes it not an integer, so no. Okay, 13/6. Let's see. Is it an integer? 6 goes in there too, but there's 1 6 left over, so no, it's not an integer. And 45 divided by 5 equals 9, so yep, that's an integer. All right, moving on. This one is rational or irrational. Remember, rational can be expressed as a fraction. Okay, square root of 2 is irrational. So it doesn't matter if it's negative or not. If it's the square root of a not perfect square, it's irrational. Square root of 1 is 1. That is rational. Square root of 1 is 1. Okay, this, repeating. If it repeats and it's predictable, rational. 13 pi. It doesn't matter how many times you multiply pi. If pi is irrational and you just multiply it by more things, it's still irrational. We didn't change it. So it's irrational. Here, 48.71. It stopped. It's a terminating decimal. Therefore, it is rational. Okay. Next. Okay, I want to talk about this because people often have trouble with subtraction, but not addition. Addition is easy. To subtract always gets people a little confused. So I want to go through some patterns. Math is a study of patterns, and it's really fun to notice stuff like this. Let's start with something we know. 5 minus 2 is 3. 5 minus 1. Basically, we're starting with 5 and we subtract 1. We take away 1 is 4. If we have 5 and we take away 0, it's 5. Look, so basically I'm taking the same number and now all I'm doing is subtracting the numbers going down by 1. And look what the pattern is. 3, 4, 5. So what's the next number going to be? 6. What did we end up doing when we subtracted a -1? We ended up changing this. We ended up really adding 1. And that's because the opposite of a negative is a positive. Think about that. If you have something that's bad, the opposite of a bad thing is a good thing. Okay, if we're thinking even like negative is bad and positive is good. So when you have the negative of a negative is equal to a positive. All right, a lot of people think of it as this. They imagine that this little guy, when they have a minus like this, they imagine that the little minus sign goes and pierces that and makes a plus, whatever works. But just know that this is a really cool pattern to notice. 10 minus 3. What does that really mean? It means you have 10 things. That's 10 right there. Okay, I'll make it a little nicer. Ready? There. I don't know why you need sound effects, but hey. Okay, you have 10, and that means you're going to subtract 3. You take away 3, and you are left with 7. Okay, I want to show you with this problem. This is an easy problem. It's just subtraction. I want to show you that to subtract means to add the opposite. Check it out. What is 10 plus negative 3? That means basically you start with 10. And let's make negative this weird green. Okay, 1, 2, 3. Okay, well, the negative 1 and a positive 1 cancel each other out. So those cancel. These cancel. One of these and one of these. One of these and one of these, and you end up with 7. So in other words, notice the difference. This one has a minus sign. This is a plus negative 3. In other words, take a look. We could actually move this 3 over here. Could we not? 10 minus 3. And what sign does that 3 have? It's a positive 3. We're taking away a positive 3. See how we took away 3 positives? Okay. It's good to think about this, you guys, because it's important to understand how they are the same. So whenever you have a subtraction problem, just remember it's actually adding the opposite. So let's say you have 3 minus 8. That is the same thing as 3 plus a negative 8. Add the opposite. I always make my kids do this when they're in class with me. Say a word for add, make a mark for add rather, make a mark for opposite. So if you had 2 minus negative 3, make a mark for add, make a mark for opposite. Add the opposite. Now it's 2 plus 3, which is 5. All right. Hopefully you got that. Let's take a look at the problems. Okay. Part of this probably is just fractions. Might be better after we've done the last chapter, but 5, 2, common denominator is 10. So we are going to multiply the first fraction by 2 over 2 to get the common denominator minus negative 3 over 2, and we're going to multiply that by 5 over 5. I hope you guys appreciate that this is really just 1 in a fancy form to make it doable. So here we're going to multiply across on the top and on the bottom. Negative 2 over 10. Negative 2 over 10 minus, okay, negative times a positive is a negative 15 over 10. Now look, we have 2 negatives together. Say the word to subtract means to add the opposite. All right, so now we're going to subtract because this one is positive. This one's positive. That one's negative. So the answer is 13 tenths. And in simplest form, generally in algebra, you leave everything like this. I don't know if they're going to want you to do this. I'm not sure if this is simplest form to them or this is simplest form to them. This is natural for anybody who's gone above Algebra 1. All right, take a look at this. First of all, I'm going to tell you that nobody writes it like this. That's ridiculous. Literally nobody writes it with a negative on the bottom. That's stupid. The negative should come to the top. Part of the problem with working with fractions is that when they don't put things at the right level, this is how you're going to rewrite that. Boom. Now it's at the right level. I don't know why that's in the denominator. That looks so bizarre. All right, you got 2 negatives. To subtract means to add the opposite. So now you have a plus. Okay, but you need a common denominator. Anytime you are adding fractions, you need a common denominator. So that is going to be 21. So we're going to multiply this one by 3 over 3 and this one by 7 over 7. And you're going to get 3 times 3 is 9 over 21 plus 14 over 21, which is 9 plus 14. Let's see, take 6 from the 9 to get 23. 23 over 21. Or 1 and 2 21s. Goes in there one time and there's 2 left over. Again, not sure which way Alex wants it. Next. All right. Again, 3 fractions. Let's look at the common denominator. You need a common denominator here, and you have 3 numbers. My trick is to start with the biggest number. And I say, 18. Does 4 go into 18? No, it doesn't actually. So we're going to have to go to another multiple of 18. Okay, what's 18 times 2? 18 times 2, 18 didn't work. 18 times 2 is 36. Okay, the reason why I multiplied it by 2 is because 18 has to go into the denominator as well. Okay, does 4 go into 36? Yep. Does 6 go into 36? Yep. Okay, so the common denominator is 36. So now you need to multiply everything. So negative 5/6 times 6 times 6 is 36. So we're going to go 6 over 6 plus 3/4. 4 times what is 36? The answer is 9 over 9. 4 times 9 is 36. 6 times 6 is 36. And then 5/18. We're going to multiply that by 2 over 2. Because 18 times 2 is 36. Again, to multiply fractions, just multiply the tops and the bottoms. This is not adding, this is multiplying. So we're going to go negative 30 over 6 plus 27 over 36. Did I put 6? I meant 36. I said 36 and I wrote 66. Where's my brain? I left it. Okay, here we go. 5 times 2 is 10 over 36. Now you're going to combine all the top numbers. Now we're adding fractions, you guys. So adding fractions means all the denominators need to be the same, and they are. So here we go. Just add your numerator. That's negative 30 plus 27. It means that is a larger number. It's negative. You subtract, keep the sign of the larger number. That's negative 3 plus 10 is 13 over 36. Next. Okay. The reason why people have trouble with these is because of the level difference. Why in the world is this 2 lower than both of those fractions? That makes no sense. If I were going to put 2 over 1, for some reason, why is it lower? Don't do that. Rewrite your fractions so they make sense. Ready? 2 over negative 5. That's just weird, by the way. Whatever. They want to play that game, we can play it. But it looks weird. You would never leave a negative over a negative. It would just be a positive, but whatever. Okay, let's multiply our tops. 2 times 16. 2 times 8 is 16. 16 times 2 is 32. Negative. 5 times 3 is 15. Times 1 is 15. Negative. We'll cancel these out. Negative divided by negative is a positive. 32 is divisible by 4. Let's see, 4 times 8 is divisible by 2. 15 isn't divisible by 2, so the answer might be 15 goes into 32 times with 2/15 left. It's either one of these two. I'm not sure which way Alex wants it. It's its simplest form. So I don't know. Okay, next, last one. Okay, divide. I want you to remember to divide means to multiply by the reciprocal. I used to have a lot of middle schoolers that would say, stay, change, flip. But I just think, honestly, can you just remember to multiply by the reciprocal? That works just fine because it's a division. Okay? Division it's a little harder to comprehend, and we multiply much better. So in the same way we change subtraction to addition, We like changing division to multiplication. So we go, no, we don't change the 2/3. The 2/3 isn't doing anything. It's being divided. So we leave that the same, negative 2/3. But to divide means to multiply by the reciprocal. Flip this sucker, negative 7/8. And you get 14 over 24, which is divisible by 2. So that becomes 7/12. And that's your answer. Okay.